Hey everyone, and welcome. Today we're going to crack open the secret to database speed, indexing. It's one of those fundamental things that can totally make or break your app's performance. You've been there, right? It's a classic story. You build something new, and with just a little bit of test data, it's flying. But then, as your user base grows, as the data piles up, thousands, millions of rows, the whole thing just grinds to a halt. So what gives? Well, more often than not, it comes down to how your database is finding its data. Because really, that's the name of the game. When you're designing a database, it's not just about storing stuff. It's about getting that stuff back out and updating it as fast as possible for what your app needs to do. At the end of the day, performance is everything. Okay, so if we want to learn how to go fast, we first have to figure out what's slowing us down. And the number one villain, the default way a database looks for things, is this brute force method called a full table scan. Just think about it like this. You've got this giant 1,000-page book, and you're looking for just one specific sentence. With no index, you have no choice. You have to start on page 1 and read every single page until you find it. That's a full table scan. Now, for a tiny pamphlet, that's fine. But for a massive encyclopedia, it's an absolute nightmare for performance.
So how do we get around reading the entire book every single time we need something? Simple. We use a cheat sheet. And in the database world, that cheat sheet is called an index.
And this right here is the perfect way to think about it. It really is like the index in the back of a textbook. Instead of scanning the whole thing, you just flip to the back, look up your keyword, and boom, it tells you exactly which page to turn to. A database index does the exact same thing for your rows of data.
So what is it, really? Well, it's basically a separate, super optimized little data structure. It keeps a copy of the values from the column you're indexing, and this is the important part, a direct pointer to where the full row is stored. This lets the database just jump straight to the data it needs, almost instantly.
All right, but this is where the real strategy comes in. You can't just go and slap an index on every single column and expect magic to happen. Nope. You have to be smart about it. Choosing the right index for the right columns is a huge part of good database design.
So where do you even begin? You're looking at a table, it's got, 10, 20 columns. Which ones get the magic index? How do you choose?
Simple. Here's your golden rule. Take a good, hard look at the queries your application is actually running day to day. Whatever columns show up over and over again in your where clauses, the ones you use to filter and find stuff, those are your prime candidates. If you're always looking up users by their email address, you should probably have an index on the email column. It's literally that simple. Okay, and generally, indexes come in two main flavors. You've got hash indexes, which are blazing fast for exact match lookups, like finding a user where the name is exactly Alice. Then you have B+tree indexes. These are sorted, which makes them amazing for range queries, like finding everyone with a salary greater than $50,000. And honestly, you'll see B+trees pretty much everywhere because they're just so incredibly flexible.
But what happens when your searches are more complex? What if you're looking for someone who is 30 years old and lives in New York? Well, you can create a single index that covers both of those columns. We call it a multi-attribute or composite index, and for those kinds of queries, it can be a huge performance win.
And then there's the special one, the big boss, the clustered index. See, a normal index is like the index at the back of the book, but a clustered index is like the book's table of contents. It actually dictates the physical order of the data on the disk itself. This makes it incredible for pulling back large ranges of data, but, and this is a huge but, you only get one per table. That's it. So you have to choose it very, very wisely. Okay, so at this point, you're probably thinking, awesome, I'll just add indexes everywhere, more speed. But not so fast. Like with pretty much everything in tech, there's a trade-off. There's no such thing as a free lunch.
I mean, it's the natural question to ask, isn't it? If they make reading so much faster, why not just put an index on every single column in every single table and call it a day?
And this is the reason why. While indexes make reading your data, your select statements, massively faster, they can actually make writing data slower. Think about it. When you insert a new row or update an old one, the database has to write that change to the table, and it has to go and update every single index that's affected. Every index you add is another piece of homework the database has to do every time you write data.
So it all comes down to balance. If you have a table that gets read 1,000,000 times a day but only updated once, then sure, load it up with indexes.
But if you've got a table that's constantly getting new data, like a log table, you have to be way more careful. Too many indexes there can actually hurt your performance.
All right, now that we understand the trade-offs, let's talk about the ultimate performance hack. When you get really good at this stuff, you can unlock a technique that is ridiculously fast. It's called the index-only scan. So check out this query. It's a pretty normal one. We're just trying to grab the manager and employee IDs by joining two tables, an employee table and a department table.
Now just imagine for a second that you've got a clever multi-attribute index on that employee table, and it includes both the department number and the employee ID. Notice something? Both of the pieces of data we need from that table are right there inside the index itself.
And that is the magic right there. The database is smart enough to realize it can answer the entire query by only reading that small, efficient index. It literally never even has to look at the main, much larger employee table at all. This saves a massive amount of work, and it's one of the coolest optimization tricks in the book.
So, as we start to bring this all together, it's pretty clear that knowing about B-plus trees and clustered indexes and these cool index-only scans, that's all super important, but that's only half the battle.
So I'll leave you with this question. What's the one thing you absolutely have to know before you even think about adding an index to your database?
The answer is your workload, the specific mix of reads and writes that your application does in the real world. You have to analyze it, you have to understand it, you have to measure it. Because smart indexing isn't about following some set of rigid rules. It's about tailoring your database to the unique demands of your application. Understand your workload, and you will build systems that absolutely fly.